Jim, I know we've talked a lot about artificial intelligence and machine learning, especially in the industrial and manufacturing space.
Mm-hmm.
And I can think of no one else in the world who could better talk about its practical applications, or maybe lack thereof, of AI and machine learning in the space. Can you tell us a little bit more about it, how you feel about it, and where you see it going in the future?
Wow, that's a loaded question, Dave.
It is.
I wouldn't say I'm the world's foremost authority. Thank you for the kind words there, but there's a lot of people that I've learned from, and I'll reference a couple of those people. But I think there's a lot of hype out there right now that probably is a little bit unwarranted, honestly. I think it's going to be a little bit more difficult to get at that value than what the hype train will have you believe. And what I mean by that is you got to remember, artificial intelligence and machine learning, really all it is just math behind the scenes. And the algorithms have been around, most of them, since probably the 50s, 60s,
Yep.
up to about the 80s, right? The issue is we didn't have the data sets or the computing power to really, make use of them. And now we do. We can actually, make use of them. So now it's, what do we do with them? And it's funny, I've even got a couple of machine learning fails, I think, from YouTube.
Mm-hmm.
It would say American football topic, and the first video would be baseball, greatest home runs ever. And you're thinking, okay, YouTube probably does this about as well as anyone,
Yeah.
and they can't get it right.
Mm-hmm.
Does that mean it's bad? No. I just think it means it's going to take a while for us to get it perfected, and we're going to have to take it all with a grain of salt. Now, let's take that to an industrial space. You get a machine recommendation, kind of like the football baseball analogy, and you have something, because a lot of people are saying, oh, we'll just let the machine figure it out and, let that control our process.
Mm-hmm.
Well, sometimes you make that decision and it can be disastrous, literally
Oh, yeah.
disastrous, right? From a
Mm-hmm.
safety perspective, or, a bad product perspective, or something like that. So I think there's going to have to be some humans involved. So I think at times it's going to be somewhat limited as to what we can do with it.
Mm-hmm.
Now, with that said, do I think it's a bad thing that we should shut down and never try? Absolutely not. And we're invested in it. Ben and I have done a couple of projects where we've looked at some things, we've looked at some different platforms, and we've experimented. We're trying to figure out so that we can be the insight for our customers. This name was picked with a purpose. We really want to help our customers figure out, okay, when do we just need to do our first principles analyses versus when do we need to do something much more advanced that we can't see, by the human eye. So a couple analogies. This is one, John Anthony's of Envoy Development. He's a good friend of mine and been a great business mentor for me. And he's been around a long time. He works predominantly in the pulp and paper industry.
Okay.
He's got some stuff in mining and some other industries too. But he really takes time series data and does a lot of statistical analysis on it. He's looking for correlations and looking for when things go, out of their normal range, which is I always tell people it's kind of like a sentry looking over your data and telling you can't trend 50,000 tags or 100,000 tags, right? So this is kind of looking at that and being a sentry for things. So he's got two great analogies that are very related that I think, if you think about it from this perspective, this is really the way to think about it. Is he said usually the algorithms will pick up human rules first,
Yep.
right? So you think about, like he's got this one, he's a little guy like me, he runs, he's like me, he runs. Actually, I don't run as much as I should. But he said, let's say I come up with a rule, Jim, that my normal weight's 150 pounds,
Mm-hmm.
right? If I weigh 153 or greater, I run 3 miles a day.
Mm-hmm.
If I'm 150 to 153, I run 1 mile a day. If I'm under 150, I don't run at all. And I run that against the machine learning algorithm, what's the thing it's going to find? You weigh
The
more?
more you run, the more you weigh.
The more you run, the more you weigh.
Yeah.
Is that true? It's a human-based rule in how we react,
Yep.
right? And if you look at a lot of our modern process plants, a lot of what we're going to see is a human and how they react to a process that's not running correctly, right? There's a lot of human noise. And as a case in point, you know, he calls me one day and he said, so I just had this customer call me and said, hey, I want to do a study between machine speed and the number of breaks we have. And he said, you know, I kind of felt like I knew the answer to the question, but I went ahead and pulled the data because I really wanted to take an unbiased look at it. And so he said, you know, what he found was a rule that he would have expected. So what do you think happens? I'm going to ask you this. What do you think happens when the paper machine starts to break more? They start to have more downtime. What do you think they do with the speed?
They turn the speed up because they are trying to make up for the breakdowns?
It's actually the opposite. They slow it down because they don't know why they're breaking.
Okay.
And they want to make waste less fast.
Okay.
Right? Because what happens is you get a break and it goes down into a pit and you can recycle it most of the time.
Okay.
You know, it depends on what kind of stuff you're making. You know, if it's coated and, you know, if it's not coated, it depends, you know, but there's a cost. They'll recycle a bunch of it, but maybe not 100%. So the initial thing you'll find is, oh, to have less breaks, you speed up, right? That's not really true. That's not really the cause.
No.
Right? It's a correlation. And machine learning and all these other algorithms are great at finding correlations. The problem is as humans, we're the ones that really need to find the cause. Okay? And because the machine and the math doesn't really know the difference between correlation and causation. All right? Is that a bad thing?
No.
As long as we don't say, okay, this is gospel and this is what we have to believe. Right? I think what we have to do is then let a human take a look at it and say, okay, there's a bunch of correlations. Yeah, we knew that, we knew that, we knew that. That doesn't matter, that doesn't matter, that doesn't matter. Because we did one, let's see, when was it? It was probably over the summer. And the stuff that I found most correlative, they said has nothing to do with it. Like, we don't even control that, has nothing to do with our paper machine quality. It was in a paper company. And so therefore, I said, well, let's take that out of the model completely, right? Because it just muddies the water. So, you know, that's a big thing we have to do is once we get the correlation back, then a subject matter expert has to look at it and say, does this even make sense? Can we make sense of this? Does this have any correlation, or I'm sorry, any causation to the actual thing we're trying to do? Okay. So those are a couple of analogies that I typically try to steer people with.
It all comes down to how you feed the data in, and also what the quality of the data is when you feed it into the model. Because the machine learning algorithms are gonna learn what you feed it and what you tell it to learn. Like you said, that model, you had to pull something out in order to find what the true, cause of that break or whatnot. So eliminating things that, from a human perspective, aren't the cause, and things that are cross-correlated so that it doesn't overly influence the outcome, right? Because you have two things that are running together, they're just maybe a similar signal, right?
Correct.
And then it overinflates like what happens. So I think that's a big part of it, and I think that's true. When you set it up, you have to have those things in mind, as well as you're working on it. It's an iterative process, right? Let's build a model, let's see how it works, check our percentage and how accurate it was, get people to look at it, get subject matter experts to really get in there and look through the results, change it up, make it better, and it just is an iterative process. And I think a lot of companies tend to think, okay, we're just going to do a quick machine learning project, set it, forget it, and that's just not the case. It's definitely a long-term building process, I think.
Yeah, probably the first machine learning project we did, you hit on data quality and how the data comes at you. We learned that very quickly because what we did was we took a very wide and very shallow data approach. We took maybe a couple thousand variables in like 1 hour, interpolated values, And the reality is we didn't really understand the signals and what was coming at us in the process well enough. Realistically, what we ended up finding out was the disturbance happened within about a 5 to 10 minute window, right? We could see it with 5-minute data. There's no way we would have found it with 1-minute data because it would have been filtered out unless we hit it exactly at the right point. The other thing that we found is sometimes the raw data doesn't tell you the whole story too. Sometimes it's a 1-minute average, or a 1-minute average compared to an hourly average, or something along those lines. And I remember this company was trying to help, and the idea was good, and I could see where in other places, other types of data sets it would have worked, was they were trying to do automatic feature engineering. And I remember, and feature engineering, all that really is a data science term where you're trying to maybe take an hourly average or do some math or some filtering on the data, where it's basically adding another column essentially. So you're adding a feature to it. And they were trying to do automatic feature engineering, and I told them, I said, well, how do you know if I need a 1-hour average or a 24-hour average? Because they were trying to do 24-hour averages. I'm like, that doesn't mean anything. Like the 24-hour average almost means nothing to us, because it looks like this disturbance happens within a very small window, and then we actually see the result hours later, right, to confirm that this was an event. And that was a very interesting process for me, to really understand that. And I think time series data really presents a big challenge in that, because the raw data isn't always the story. Whereas if you're using a lot of relational data, that is your data set. That is the story, right? Here I might take a flow that's a really noisy signal. It's really the hourly average or the daily or monthly average that tells me the story that I need to know for a machine learning algorithm. And so, that's an important thing that a lot of people just flat miss. We missed it when we first started doing it.
Yeah, I think part of that too is, when you have the raw data, you may have missing values, you may have things where the sensor went to 0 or errored out or different things like that. And that's something you have to look for when throwing data into a model. You never know, you're going to get a bad outcome if you have bad data, right?
Yeah, and fortunately, most of the tools we've looked at do a really good job at the filtering part, right? Several of the tools we've looked at, even the one that was not very successful for us, they did a really good job of helping us find those anomalies and get rid of them, right? And so, that's something that, a lot of the machine learning companies will kind of brag on, but, the reality is they all do it, and they all do it relatively well,
Well, part of that as well is you want to filter out things that maybe the algorithm's not going to say is wrong, but the machine was down, or you're running a different style of process, or something different happened in real life that you couldn't just tell from an algorithm from a software perspective.
Correct.
But it's a human filtering issue. So sometimes the raw data isn't always the best.
Yeah, no doubt. We did an interesting project like last year. One of our customers invited us to, they're using a multivariate data analysis tool called Simpa, which is made by Sartorius Steedham, which used to be Umetrics. I think they bought Umetrics. So it's in the machine learning family, but it's principal component analysis, or PCA, and PLS, partial least squares. So they're a very linear, correlative kind of a thing. So if you have a process where if this goes up, this should go down, and it's a very linear correlation, these kinds of tools will do a great job at it. It's if this goes up by 5%, this increases by 50%, where it's more of an exponential, it doesn't find that stuff as well. But we were doing a training course with them, and the way that their people had always looked at the data was they were taking raw data in 1 minute, 5 minute, 10 minute, 15 minute chunks, right? And they were saying, hey, what changed? Or they would ask a specific question, which we'll get to here in a minute. But we took a little different tact. We said, okay, this was a Pi customer, so we took event frames. And we said, hey, let's take a look at time series data over each event, and let's look at when they make this product and they run it well, they don't have a lot of downtime. versus this other time where they run the same product and they have a lot of downtime. What's different between those? So we were kind of taking the data and putting it in different forms to ask different questions of the data.
Yep.
And most people don't think of it, and the data scientist doesn't even understand that. Right.
Okay.
The typical straight up data scientist doesn't necessarily understand that. They're great at the math behind the scenes, but they don't know that, hey, I have this product that I've run 15 times over the last year, 7 times I ran it great and 8 times I ran it horribly. They don't necessarily understand that, right? And they don't know to ask those questions. And I think what we've kind of found is our role is probably going to be in this. We're probably never going to be that true data scientist. I don't think we'll probably hire some people down the road that are, but like Ben and I's role and other people like Eric and some other people we're considering hiring, our role is going to be the translator between the two.
Because you understand the process, and the process is so important to understanding what the data is saying to improve.
No doubt. And then how to actually get the data and what form it needs to take on, right? Because really what we did was feature engineering. Because we looked at that one particular product run, from a different perspective. That customer had never looked at their data that way because they had never used Pi that way to look at it and contextualize it. And the thing is, I think pretty much any of the data sets, we didn't have to necessarily use Pi. We could have done some of that filtering with other things, right? But, it was a very interesting kind of a play for us because we wanted to see like how can all this be interrelated. So data quality is huge. How you do the feature engineering is huge, and you have to have a human involved. Until maybe 50 years from now, when you're still working and I'm long since in the grave. No, I'm just kidding. Maybe we'll figure out how to do it all automatically. And it'll probably even happen in my lifetime. It'll get better. But I think right now the hype train says, oh, this is where we're at today. And I think we're still years from that.
Automatically scares me. I have been telling people for 10 years, if they have an unlimited pot of gold, we can build them a manufacturing facility that they can wake up in the morning, they can turn on their smartphone, they can press a button, and it'll go. And we could, in theory, do that, similar to how we could, in theory, install artificial intelligence that can make in-process changes. But everything that can go wrong in any of those situations just scares me. If you're giving a machine that doesn't understand the process because the people that built the machine don't understand the process well enough, because I'm not sure any of us understand a process well enough to take a human out, and you're giving that the ability to go and accidentally make something explode.
Yeah.
That scares me. That's what scares me.
It scares me too. I think there are some processes and industries that lend themselves more to that. I've heard of lights out facilities, for a number of years now, right? It's not like it's impossible to do. I think, like the paper industry is one we work in a lot, right? I think there's so much that's not well known, coming in. Like you have experts that know how to run a paper machine, but there's like this, one really critical piece of data. What does your chips, your chip quality look like? Hey, these logs sat in the field for a month, and then we brought them in, and then they sat at the bottom of the pile and got rained on for 3 months, and those are the chips I'm cooking today. Tomorrow, I take chips that I just got, they were fresh cut, thrown on the truck, freshly cut. Those are going to run differently, right? I've asked several pulp mill managers, do you even know which set of chips that you're running? No, they don't.
Never.
Right? Well, then you're going through the digesting process, washing, bleaching. You're going through several processes before it hits the paper machine. And then you've got people turning knobs, crew A, B, C, and D all turn the knobs differently.
Always.
Right? So there's all these like interrelationships that just create noise in a model. Okay? Now, I think that process is very difficult. Okay? I think, on the opposite side of that spectrum, you look at the drug makers, right? Pharmaceuticals. We know that Simpa Online is doing some things in pharma, and I think some in the chemicals industry. It just kind of depends. But they are doing that kind of monitoring.
Mm-hmm.
And if they run, like basically what the model does is it creates a tube, and if you keep your entire process in the tube,
Yep.
then you don't even have to do final product quality tests.
Mm-hmm.
You've nailed it.
Yep.
So it's not like it's unprecedented, right?
I know people doing that.
Yeah, it's not that you can't do it. I think there's a lot of processes that are much more difficult to do it with. And, the first project we worked on, I remember telling the plant manager, I said, if you could have just let the process crash,
right.
we'd have a great model, right? He's like, well, Jim, I can't do that because it's literally a 7-figure problem if it happens, right?
Yep.
Or it could be.
Yep.
It's not always, but it could be. So you think about it, you can't let the process crash to get a good model. So what's going to happen is that the humans are going to tweak on it or stop before it crashes. It's kind of like, okay, well, what we have to do is let these self-driving cars crash to know, we should have trained it differently, right? Well, that's fine, like on a test track in a controlled environment. We're talking about production facilities that are making hundreds of thousands of dollars, millions of dollars, a day, a week, a month. You can't just let it run into the ground, and we're gonna struggle to get our models right sometimes.
Yeah, I was gonna say, like, it's definitely, that's again the iterative process, that idea of can't let it crash, but we can get it when it starts to fail and start to catch those edge cases, and then you start to pick up other edge cases until you get a bigger, broader picture of what you're trying to do.
Yeah.
I think, you don't necessarily have to let it crash.
Right. Yeah.
Right?
Yeah.
But it takes time still to pick up, and then maybe that operator might not turn that knob so far the next time, and
Right.
you pick up those cases. So yeah, I think we can avoid some of those catastrophic things, or I know people do a lot of like planned, like, okay, we're gonna not do a crash, but we're gonna test something that we know specifically to see
A
how
design
it
of
behaves.
experiments. It's a
Exactly.
design of experiments.
A DOE.
typically. Yep.
And people will do a set of those if you have the opportunity to, but a lot of times
Correct.
people don't have that opportunity.
Yeah, that
Yeah.
really goes hand in hand, is because if you build a model and you start to find things that are causing the problem, right? You do a design of experiments and say, can I repeat this? Right? I'm not a design of experiments, expert. I know the term and I know the basic premise behind it. So please, if you're watching this video, hey, I'm going to go to Jim and have him help on DOE. We know people who can help you, but we're not it. But what we do know is kind of where it comes into play. That's a huge thing. I think one of the biggest places we could and should use machine learning and multivariate analysis is to help the subject matter expert eliminate ground. So I was at a facility probably, I guess it was in August, and we go by this guy's office. He's a subject matter expert, been there probably 20, 25 years. Really intelligent guy, right? And I'll call him Johnny, right? That's not his name. I'll protect the innocent here. But Johnny they were a pie customer. Johnny had a process book screen up there, and there's probably 30 pens on the screen, right? I mean, there's just squiggles everywhere, right? And he's clicking through, and I'm like, Johnny, what are you doing? He said, oh, well, we've had such and such problem, and I'm trying to kind of understand what correlates with it. So let's think about this. So he's had a trend screen up, and he's trying to go back and find all the specific times where they had this specific problem and look back before it happened, and he's throwing all these variables at it and then having to build a bunch of these to figure out, does all this stuff line up? And I'm like, I really just took my head and kind of started beating the wall, like, no, don't do this, Johnny, please, right?
At least he was trying.
Oh, he's excellent at it, to be honest. He's great at it, right? And to be fair, he's a boomer. He's going to be retired in 5 years. Okay? These are the tools he's had. And, I'm not picking on Johnny, right? But what I said was, man, why don't you give us a data set, let us run it through Simca or one of the other tools that we've been playing with, and let's find out what seems to correlate and what definitely does not correlate. So then that way, instead of 200 variables that you're looking through, maybe we give you 20. Right? Maybe we use event frames to you give us the conditions of when these things happened. And so we understand like what, you know, we narrow the field down of what we're looking at, you know, as far as from a data perspective. And then we tell you, okay, these 20 things seem to potentially line up. And then you can do this analysis, right? Because we're going to need you to tell us anyway.
Yep.
So, you know, that's where I think the benefit's going to be is let's eliminate ground, right? But then let's get the human back involved to see, okay, did we, you know, find the problem? Did we find something that is correlative or could potentially be causal?
I might need to get these on.
There you go. Squeaky.
Gotta get the height right.
Yeah,
Oh yeah, that chair is definitely squeaky.
it is squeaky.
Do we have another one?
No.
I'm trying to think.
No.
Yeah. Just go with it.
At least we now have a bumper at the end of the video.
Yeah, there you go.
Or my bloopers video that I would put out directing towards Jim's video.
Yeah.
It'll just be Ben talking about the squeaky chair.
Yeah, there you go.
I doubt this is actually going to be a real thing.
Have you not seen my videos?
Just a joke.
Oh,
That's for
okay.
the video.
I remember. I've got a.
That's how
first-
you make it exist.
Yeah, I did a personal one. I like did my casting bloopers with the Benny Hill thing behind it.
I like it.
So yeah, I mean, like there was one like I had the rod sitting here and I went whack, you know, and like stuff just tangles everywhere, you know, and I slowed it down. You hear me whoa, whoa, whoa. So yeah, I like blooper videos. They're
I like
funny.
blooper videos too.
Yeah.
Half of my life is a blooper video.
There you go.
It's a good percentage.
Ready to get started?
Yeah. Okay.